State whether the relation is a function. Find the inverse and state whether the inverse is a function. So from yesterday, we already did this part of finding whether or not it's a function. So we have two things to answer. Function, yes or no. And then we have inverse. Is that going to be a function as well? Yes or no. So for the first part, it should be simple. The x values are -1, 3, 4, and -2. None of those repeat, so there's no y values to take a look at. So in other words, this one could be a function, yes. But you have to find the inverse of this relation and see if that inverse is a function. The way you do that is simply flip those coordinates. So you're going to end up with 2, -1, and then -1, 3, and 3, 4, and then 6, -2. Okay, so take a look at that and determine if we're still going to have a function or not. You say yes. Okay, why is that? None of the what numbers are repeating? None of the x values are repeating. Okay. So in other words, we could go with yes. Or not yes, but I circled yes and said no. That's not good. So we'll go there. First of all, is this a function? Yes or no?
Yeah.
Yes, we have 4, -2, 4, and then 2. None of those repeat. So that one would be yes. So now without writing them in the reverse order, just with your eyes looking at it, do any of these repeat in red? Which one repeats?
4 and 2.
They both repeat. So we'll look at the 2. Are these the same numbers? No. Okay, we'll look at the 4s. Are these the same numbers? No. All you need is just one pair to show that. So in other words, the inverse of this function would not be a function. As this is written, is this a function, yes or no?
Yeah.
Yes, it is. Is the inverse a function? No. Why not?
2 3s.
You have 3's, and then these don't match up. So the inverse is not a function. Here's some practice. On your paper, all I need to see is your last name with F, yes or no, and INV, yes or no. As it's written, we have a 2, 3, 6, and then a 3. So this and this repeats. These are different numbers, so that is a no. Now let's look at the y values. And we have a -1, -2, 3, and -6. None of those repeat, so it's yes. Determine whether the inverse of each function graphed is also going to be a function. And the way that you can do this is with a line test. We've already done the vertical line test, which determines if this is going to be a function or not. Would this be a function? No. But in blue, we can do the horizontal line test. So if I go like this, no matter where I put a horizontal line, I'm only crossing in how many places? 1. So if you only cross in one place, then the inverse would be a function. Here's a horizontal line. Is the inverse a function? No, it crosses in how many places? 2. All right, bring this one up. Is the inverse of this function a function, yes or no? The answer, here's the horizontal line test, and that would mean that the inverse is no. Yes or no, is the inverse of this function a function? Here is the horizontal line test, and no matter where we go, it's just going to be one spot. So the answer is yes. For each function, find the inverse. Then use composition to verify that the equation you wrote is the inverse. We'll get into composition in a little bit. I want to focus first on just the steps to finding the inverse. Then we'll do composition. Alright, the function is y equals x minus 6 over 2. In order to find out what the inverse of this function is, you must trade places with the x and the y. So it's going to be x equals y minus 6 over 2. And once you do that, then you start solving for y to get y by itself. That's why we did that section days ago where you had to solve an equation for a specific variable. Okay, so to get y by itself, the first thing we could do is multiply both sides by 2, or we could treat it as this. Cross multiply. If we cross multiply, we get 2x equals y minus 6. And then to get the y by itself, we can do 2x plus 6 equals y. But the inverse is noted differently than the original function. That's the inverse. And if it's written like this, f of x equals x minus 6 over 2, then you would write the inverse as this. We have to find the inverse of this, and there's nothing that says you can't rewrite it before you find the inverse. So just distribute the 5 through the parentheses to get 15x plus 20. So now you can find the inverse of that. You have to switch the x and the y. So you're going to come up with x equals 15y plus 20. And then go through to solve that for y. Move the 20 to the left, and then divide by the 15. So x minus 20 over 15 is the inverse, so we'll put y to the negative 1. Find the inverse and switch the x and y to start with, so x equals a negative 2/3 y minus 8. And bump the minus 8 to the left. And then you would have to divide both sides by a negative 2/3. These cancel out. So we're left with a y on the right, and then over here we have x plus 8, and then over a negative 2/3. You can write it like this. That's the same thing as saying x plus 8, that quantity multiplied instead of divided by a negative 3 over 2. Flip and multiply by the fraction. So when I do that, I would have a negative 3 times the quantity x plus 8, and then that over 2. And remember, we're now getting the inverse. You can simplify that and make it negative 3x minus 24 over 2. And depending on how answers are shown, you could have something equivalent to that. Something equivalent would be negative 3/2 x minus 12. But if you have that, that's okay. If you're on a multiple choice test and you come out with this and it's not listed, then chances are you'd probably have to divide it out and come out with this. On a short answer test, if you left it like this, I'd count that. If you went there, I'd count that as well. Using a graphing calculator to graph each function and use the horizontal line test to determine whether the inverse is a function. I'm not so certain that sentence is grammatically correct, but use a graphing calculator to graph each function and use the horizontal line test to determine whether the inverse is a function. So I guess it is correct. Anyway, there's the function. So by now we've been through the many steps of being able to plug in a function into the calculator and graph it. So if you put in 2x to the third plus 3 and then graph it, you should get something that looks like this on your calculator. The horizontal line test says that no matter where I draw a line in here, that the inverse would be a function because we're crossing at only one spot no matter where the line goes. Negative x to the third minus 2. Yes or no? Would that inverse be a function? The answer would be yes. This is the graph, and no matter where we draw a horizontal line, it's just crossing in one spot. So that would be an inverse that is a function. Would the inverse of this function be a function, yes or no? The answer would be no. See the next slide. Here's the graph, and if I do a horizontal line, notice I'm crossing in two spots, so the inverse is not a function.